Hi, welcome to another edition of Design Spark Ask the Expert. Today we're joined by Marie-Louise Sharp from Schneider Electric to discuss the importance of backup power systems in the face of the European energy crisis. Marie-Louise is a European Regional Offer Director for Schneider's IT business, focusing on single-phase UPS, rack systems and edge product lines. With 21 years of experience with Schneider Electric, Marie-Louise has held many roles spanning channel management, project and product management. So Marie, energy crisis. We're all facing it. Bills are going up. Everything's going chaos. It's all chaos. Obviously,
Absolutely. And I think particularly here in Europe, it's very easy for us to take energy for granted. However, the latest indicators do show that Europe is very much now in the midst of energy crisis mode. And there's a lot of uncertainty in terms of the capacity and the resources to keep the lights on, in effect.
mm, so businesses are going to be affected. Possibly homes are possibly going to be affected as well. People aren't going to be able to cook if we end up with things like grids overloaded. Grids can collapse, cause lots of problems. People tend to start talking about backup power a lot, and I've personally looked at things like UPSs and generators. Even at home, I've considered things like, can I run a small generator to keep things on should the lights go off? Obviously, UPSs are important to people. What effect does having a UPS have on people? Like, what would happen without a UPS, for example?
Well, the potential impact that power fluctuations and power outages can have both in the home and residential environment as well as in business is actually massive. If you think of the residential space, power
Hmm.
fluctuations that would result from an unstable power grid, they're actually capable of causing disruption and even damage to your home office computing devices and all your home entertainment equipment. As it's the run up to Christmas, you go and get yourself a nice new expensive television. You want to make sure that that television is protected. And furthermore, a full power outage could affect critical smart home functionality. A lot of houses these days have lighting, heating, and security devices that are all controlled fundamentally that they need power to function.
Hmm.
If we think about the business application, businesses are heavily reliant on critical IT infrastructure to keep that business up and running. So the repercussions of power surges and outages can be really devastating, um, particularly in the unstable power grid that we find ourselves in right now. This could have a massive detrimental impact in terms of productivity, again, damage to equipment, loss of data, and of course, all of this can equate to potentially huge financial losses. If you think just of the more extreme end of the business scale, take a data center at a customer's site. Downtime in a
Hmm.
data center, the average cost of a data center outage is estimated at around 740,000 euro. That works out to around 8,850 euro per minute in lost revenue and unproductive employees. So it's quite a big impact.
Even for big companies like Google, Facebook, Amazon, all the rest that have massive data centers around the world, that is still an enormous cost. So it really does demonstrate,
Absolutely.
puts it into perspective, really, the damage that having poor power, sort of no power can cause. And I know even for us, if we lost power and if poor power quality destroyed, we've got a small NAS in the office. If we lost that, it could be a day or two restoring
Well,
from an
I
offsite
guess if
backup
you
and
were
getting
unable
everything
to
back
process your
into.
customers' orders, it would have a big financial impact.
Yeah, yeah, it's that's really surprising. It adds up so quickly. I mean, I expected costs, but not quite that much per minute for a big site. That's really surprising. So you mentioned things like poor power quality. What features would a UPS offer that helps work around these issues that you could find in a poor power situation?
Sure. So the main function of a UPS or uninterruptible power supply is to be there to provide battery backup. So in the event that there is a power failure, your equipment that's connected to your UPS stays up and running. But that's not the only function of a UPS. even if you were not to have a power failure, that UPS is providing, depending on the type of UPS you buy, which I'm sure we'll talk about later on, it's providing what we call clean power to that device. So, what do I mean by clean power? Well, in an ideal scenario, when you plug something into your socket at home, you would be getting 230-volt voltage, 500 hertz frequency, and it would be an absolutely stable supply. The reality is that the grid and electricity is rarely uniform. Voltage can be higher or lower than expected. I don't know if you've ever been working and you've seen the lights suddenly go bright and dark. So a
Yep.
UPS will also provide a stable, non-fluctuating power supply. And again, that helps to prolong the life of your connected equipment. The last thing that a UPS would protect against would be what we call a surge or a spike. So a power surge is what we would deem as a temporary increase in voltage on a power line. So usually this is between 10% to 35% above normal voltage and can last anywhere from a few milliseconds to several minutes. And what you really want to have in your UPS is make sure that you're not just protected against power failure, but you're also protected against these surges and spikes. And in terms of surges and spikes, those are typically measured in joules. So if you see a joule rating on either a surge protector or a UPS, that's letting you know how much of a surge or spike that device would be able to handle with your equipment connected.
So it is really quite important to have clean power for things, particularly the point that you've raised on over voltages. You can picture that quite easily, stressing components inside things like power supplies that then cause a failure. You could have things like capacitors in a power supply that could explode if the surge is high enough in voltage, really. So it has the potential to cause a lot of damage.
Absolutely, 100% right. And if you think of the value of all of these devices, even in your home, I'm sure this is like having an insurance policy for all of that equipment to make sure that you're not affected by any sort of lightning strike or anything like that.
I know from personal experience, I've got a sizable laptop, and the power supply for it's a 230-watt power supply. A surge killed that, and a replacement for that was, I think, £150. It's quite a lot of money, even just for something small like a
Absolutely.
power supply. So for when you've got a big power supply for things like a server, it'd be even more expensive. So it is really important. So you mentioned as well, obviously, one of the main things that you get with the UPS is the battery backup. Batteries are advancing in everything. Phones now have lithium batteries. Cars have lithium batteries. There's continually news articles about advancements in battery technologies. Are UPSs catching up with these advancements in battery technologies?
Absolutely. So still, I would say by far and away, the most common type of battery found in a UPS is what we call a VRLA, voltage regulated lead acid battery. So the type that looks very similar to like a car battery, right? However, we're seeing a lot of newer topologies of battery coming to market. You mentioned lithium ion. Lithium ion is being adopted by all sorts of industries, obviously, even most notably the car industry in recent years. And there are a number of benefits of using lithium ion batteries. So at Schneider Electric, we actually have a large number of options available for customers that have lithium ion batteries in them. And really, the key advantages of maybe spending that little bit more money up front to have the lithium ion battery is that lithium ion loses much less capacity than VRLA when used. So over time, all batteries, I'm sure you've seen it with your own mobile phone or with your laptop, over time that battery loses capacity. With VRLA, that happens a lot quicker than lithium ion. Also, VRLA batteries are very affected by higher temperatures. An interesting fact for you, temperature is probably one of the main killers of VRLA batteries. For every 8 degrees Celsius rise in temperature, that a UPS is kept in. So if you kept it in a hot warehouse, for example, rather than in a nice cool server room, for every 8-degree rise in temperature, you're actually cutting your battery life in half. Whereas with a lithium ion battery, it has a much higher tolerance for higher temperatures. You get a significant amount of additional cycles. What I mean by cycle of a battery is when you discharge and recharge that battery. A typical VRLA battery, you're talking about 500 cycles, and depending on the usage and the temperature, 3 to 5 years design life. Versus a lithium ion battery, we're talking 5,000 cycles. So compare that to the 500 cycles of VRLA, and a lifespan of 8 to 10 years. So really, lithium ion has a strong TCO, or total cost of ownership, message around it.
Yeah, because I guess the thing with the VRLA, like you say, is the lifespan's a lot shorter, so you've got to replace them like maybe every 3 years. I know I have a UPS at home that I bought it maybe 3 or 4 years ago now. That's in need of new batteries, and the batteries for them are not cheap. They're a few £100 worth of battery that goes into it. So it's, to do that every 3 or 4 years, it really does add up.
Absolutely. And think of it in the business context as well, where maybe the UPS is somewhere where there's no IT personnel on site. So when that battery needs to be replaced, you've got the additional cost of actually sending someone out to site to swap out that battery, plus the labor, the transport, etc., etc.
So it adds up even more, really. So that the advantage of the lithium ion there lasting a lot longer is like you say, the entire total cost of ownership is a lot lower because you're not sending maintenance personnel out all the time. You're not having to buy replacement batteries. It's installed. Presumably as well, the move to lithium ion makes the UPS lighter as well.
It does, up to 50% lighter.
So if you,
So that
another,
makes it
that's a
much
good thing
easier
for
when you're
small
actually
sort of,
installing these, because it's much lighter.
yeah. And if it's up high in a small server rack as well, or a small network cabinet, try to get it, like you say, try to install it, get it up there. It's a lot easier. It's a lot safer, really.
Yep, definitely.
So presumably everyone talks about UPS. People think you just go out and buy a UPS. You size it roughly to your load and everything, but presumably there is different types of UPS available.
There is indeed. So there's actually more than three, but there's three primary UPS topologies, which are the ones that you find most commonly. So the first one is sometimes called a standby UPS. It's also sometimes referred to as an offline UPS. And then you get line interactive and online UPSs as well. The reality is, all three of these different topologies can meet the input voltage requirements for the equipment that will be plugged into the UPS. However, there's differences in how that result is actually achieved, as well as the frequency and amount the battery is actually being used in the UPS. So if I go to that first topology that I mentioned, standby or offline UPS topology, this is by far and away the most cost-effective topology available. So if you were to, go onto a website and be looking for something for your home office, it's most likely that it's going to be an offline or standby UPS that will be the first thing that will pop up in your browser. So it provides surge suppression. And again, the amount of surge suppression that you would get would be dependent on the joule rating of that particular product. But here's the difference. It's only really providing battery backup in the event of an input voltage sag or power outage. So the type of UPS power equipment powers the equipment off the utility power while providing continuous surge protection. And then it only switches to battery mode during these voltage sags or outages. Standby topology is best suited, I would say, for your home office type application, maybe point of sale where it's at a retail store, protecting a credit card machine, things like that. That's really where you'd probably see an offline or standby UPS.
So that's tailored well to small loads where it's like you might occasionally suffer power glitches, you might suffer a loss occasionally. It's not super duper critical in a way that if you lose power, you can shut down safely and then carry on when it comes back, kind of thing.
100% correct. Yeah. The next topology is line interactive UPS topology. And
Mhm.
this is the most widely used topology in the industry. And I mean, as in Schneider Electric, we have literally hundreds of millions of these installed worldwide.
Mm.
And it's a very efficient UPS. So the
Mhm.
way that line interactive works is that it's actively regulating the voltage. So as I mentioned, you're never getting that true sine wave out of your plug socket.
Mhm.
And it's constantly dipping or going above the ideal kind of threshold. So what a line interactive UPS does is it regulates that voltage by either boosting or decreasing the utility voltage as needed
Mhm.
before allowing that voltage to actually pass through to the protected load. And you'll sometimes hear that feature referred to as AVR, or
Mhm.
automatic voltage regulation. Now, it's still not a true sine wave unless it's a line interactive unit with true sine wave output. It's more than likely what we call a stepped sine wave. And I'm sure we can probably put some images up in the video to demonstrate this a little bit better. So the last topology of UPS is what we call an online UPS, or sometimes also referred to as a double conversion online UPS. And this is the Rolls Royce in terms of UPS, and it's designed really for highly sensitive loads and is ideal for use in environments that have got poor power quality. Unlike the other topologies that I was talking about previously, an online UPS is the only one that provides zero transfer time going onto battery. And the reason for this is that the online UPS is creating a true sine wave output. And the way that it does this is it takes the AC power coming out of your plug socket, converts it to DC, and then back to AC again. So you're getting that true sine wave output. And this makes these types of UPS best suited for highly sensitive equipment, whether it's PLC power supplies or high-end IT equipment, where you want to make sure that there's that zero transfer time and that you're getting the optimal input coming into that device.
Mm. So the double conversion is effectively always sort of keeping the batteries maintained. It's always ready to go. It's sat there ready and waiting to go.
It's working the whole time. So it's
Mm.
actually converting the AC to DC and then back to AC. It's not waiting for an event to happen. It's making sure that that load is clean on
So
the
no
other
matter what
side.
happens on the input, the output's always going to be pristine. It's going to be perfect for feeding into your equipment, and it's all going to be
Correct.
quite nice and happy.
Yeah.
So they are, if you were a big company, say, or a data center even, they're the UPSs that you'd be looking at to put in your data center. It's like you go for a double conversion because then everything is fine. It's all very clean. It's nice, and all your equipment's going to be really happy with that. So you mentioned the other
Yeah, it
thing.
depends. We see a mix of line interactive and online in the data center. Sometimes if it's a more smaller server room, because IT equipment can actually cope quite well with that sort of 2 to 4 millisecond transfer
Hmm,
time that we have on a line interactive UPS. So
mhm,
I'd say we see line interactive and online, but in a big data center, yes, it would be a double conversion online UPS for sure.
hmm. So obviously, UPSs, we've looked at the different type of topologies, the different topologies of UPS now. How would you go about sizing a UPS? Because obviously, you look at one and it says, oh, it's 700 VA, fine. You kind of go, yeah, my desktop might pull 500 watts.
Mm-hmm.
How do you size a UPS? What is there any tricks to sizing a UPS?
Yeah, absolutely. So, the 5 questions that I learned to ask when I started working at APC,
Mhm,
these are the sort of the five main questions that you need to ask your customer or you yourself would need to think about when trying to select a UPS. So,
mhm,
the first one you kind of touched on already, and that is load, right? So, what is the load? How much of those watts, volts, etc., do you
mhm,
actually need to support your equipment? So the load is the total electrical power draw of the equipment that needs to be connected.
mm,
Now, as you pointed out, UPSs are usually measured in kVA or VA rather than kilowatts. And that does sometimes make things a little bit confusing. So, not all UPS models have the same, what we call power factor. Now,
Mm-hmm.
power factor is a measure of how effectively your equipment is using the electricity. So,
Mm-hmm.
it's the ratio of working power, and it's measured in kilowatts to apparent power. I know this
Mm-hmm.
all gets a little bit complicated, but to simplify it, the higher the power factor,
Mm-hmm.
the closer the watts or the watts will be to the kVA. So, for example, if you had a 1 kVA with a unity power factor or a power factor of 1, that
Mm-hmm.
means you're actually able to support 1,000 watts. If
Mm.
it had a power factor of 0.8, it would be able to support 800 watts
Mm.
because you lose some of that capacity of the
Mm-hmm.
UPS. The next very important thing to consider is runtime.
Mm-hmm.
Now, this is the amount of time that you want the connected devices to remain switched on in the event of a power outage. One consideration here, obviously, the more the runtime, the more
Mm-hmm.
batteries you're going to need, the more expensive the solution is going to be. So I would say that over 90% of power interruptions are really, really actually short in
Mm-hmm.
duration. So I would say the typical runtime that customers are looking for is usually just around 10-15 minutes. It's just usually enough time for them to power down their devices in a safe manner. Make sure that, particularly if it's in a server room, that IT equipment is shut down
Mm.
correctly. The third question you may want to consider is expansion. So, are you or is the customer expecting to add more equipment to the UPS in the future? And
Mm-hmm.
if so, how much? Because you might want to plan for that future equipment at the time that you buy your UPS rather than having to then buy a second UPS for additional equipment.
Mm-hmm.
The fourth consideration I would say is form factor. So, where are you actually putting this? Are you putting it on a desk in an office? Are you putting it into a rack enclosure? Because you need to know whether it's going to be a floor or a wall mounted or a
Mm-hmm.
rack mounted solution that the customer wants. So, what best suits where it's being deployed? And then lastly, I would say the next most important thing is the application. So,
Mm-hmm.
what type of equipment needs protecting, and how critical is that to your operations? How many outlets do you need in terms of plug outlets to support your devices? And actually, once you have the answers to all of those questions, it's super, super easy because actually at APC by Schneider Electric, we have a very handy UPS selector that will actually take all of the guesswork
Mm-hmm.
out of right sizing the UPS to your customer needs. And you would simply fill in the answers to those questions that I just
Mm-hmm.
mentioned above, and it will actually help suggest the most suitable UPS, and we'll give you a comparison of maybe 2 or 3 different UPSs in the range to consider. So that's my go-to. I'm not a physics major. I know I speak a lot about kVA, watts, volts, amps, but the UPS selector really takes the guesswork out of everything.
Mm. I guess it gives you a few options as well, and to look at whether you want to go a bit bigger, a bit smaller, what would be perfectly sort of in the middle. It gives you all those options, so you can then say, yeah, we'll go for the slightly bigger one based on these expansion capabilities, things like that. Or you could go for the one that's perfect for now, and if you know you're not going to upgrade later.
Absolutely. Also helps you selecting any accessories that you might want as well, if you wanted to have an extended warranty, for example, or anything like that.
So expansion capabilities as well. You mentioned like the runtime of the UPS. Do some UPSs offer battery expansion, so you could size one for whatever future load, and then decide to upgrade the batteries later on, expand them to increase the runtime.
Yes, so not all UPSs are capable of having multiple battery packs attached to them.
Hmm.
So if you're trying to get a really long run time, you're probably going to need to go for an online UPS, because typically they are the ones that are capable of taking 5, 6, 7, 8 battery packs connected together in series. What I would say is just remember, the longer the runtime, the longer it's also going to take to recharge all of those batteries when they're depleted. So if you had 5 or 6 battery packs connected together and you run them completely down, it's going to take quite a long time to recharge all of those back up to 100% capacity again.
So that could be a drawback if you're in an area that's prone to power cuts, but you're trying to get the long runtime. Is it'll also then take a long time to recharge, so it might not be the best solution, really.
Yeah, and there you may want to consider a two-prong approach, right? By investing in a small generator of some description, because bear in mind, the disadvantage with generators is they take time to start up, right? They're not instantly on. So the combination of a UPS and a generator works very well, because the UPS will keep everything going to allow enough time for the generator to actually start up and then take over.
So it's kind of that, it fills the gap, and it'll also, I guess, as well, like you say, you might want to go for an online with that topology. It'll also cover any sort of, it'll tidy up the power coming out of the generator effectively, because it might be quite noisy power coming out of the generator, and in the online UPS will then tidy that up and give you nice clean power regardless of what's going on.
Yep.
Excellent. So it sounds like there's plenty of tools available there for selecting a UPS.
Definitely. And as I say, if I was going to encourage anyone to think about investing in a UPS, I would say it is now. With the risk that we have of power cuts, and we just can't guarantee that supply is going to be there anymore, given the strain that there is on the power grid.
I think I'll definitely be using that as an excuse to replace my UPS batteries at home.
Just absolutely.
Keep me going through those power outages.
It's no good if the batteries don't work, right?
Yeah, exactly. It never works and it beeps at you instead. So
yeah.
Well, there's definitely been some interesting statistics in there.
Well, thank you for inviting me to come and talk about this subject today. I really appreciate it.